Maybe everyone is thinking, why mental computation in the middle of this all science? I think that we have common ideas, and when we talk about inquiry-based learning in science, it is also important in mathematics, and we need to discuss ideas. And maybe in the final of my presentation, you will find some common ideas that I share in mathematics education with science education. So before I explain a little bit more about my experience, I want to challenge you to compute mentally. So you need to feel how it was done with students in school to understand the potentialities of the work that I've been doing. So I'm going to present you two questions, one mathematical expression, very simple, and a little word problem, and you have 15 seconds to solve the first one and 25 seconds to solve the second one. So, doesn't work.
Did the kids break it?
Okay.
No.
So, are you ready to compute quickly? So it was hard, especially almost at the end of this conference. Maybe it was not very easy to think fast. But let's see how the students who participate in this study think to compute 10% of an unknown value that they know that is 5. So João said that I found out that 5 is half of 10. The missing result had to be half of 100. 10 is compared to 100, so 5 have to be compared with half of 100. So that is 50. So what kind of information can we understand from this explanation? First of all, we can see that João can make a lot of relationships. He relates the parts, 10% with 5, and he relates the wholes, 100% and 50. And this kind of relationships is very important when we are working with rational numbers. Concerning the second one, how many buckets of a half of liter water are needed to fill up a tank with a capacity of 22.5 liters. This can be solved using this mathematical expression, right? But sometimes we don't need to use this formal expression, we only need to think about it. Like Eva, I don't think it's not our Eva from today, but Eva said that it's 45 buckets. I multiplied 22.5 by 2, and it is a half of liter bucket. To get the unit, you have to add 0.5 twice. So I multiply 0.5 by 2. What can I see from this explanation? First of all, that Eva knows several representations of half. It's not only in fraction, but also in a decimal. And also that she knows the relation between, these explanations show us the relation between divided by the half and multiply by 2. And also a very important thing that it calls operation sense is that normally students think that when we multiply, we get a bigger result. When we divide, we get a smaller one. But when we are working with rational numbers, it don't need to be this way because we are working with numbers less than 1. So this is very important to discuss in the classroom. And this kind of simple things lead us and give us this opportunity. So why? Why mental computation? Why discussing all these things? First of all, there's a big emphasis on developing mental computation with natural numbers. But when we go further with other numerical sets, like rational numbers, real numbers, and so on, we forget mental computation and we go on to the algorithms. But we need to continue to construct relations between numbers because this is very important for our lives. So it's important to make relationships between contexts in between mathematics. The word problem that I show is very simple one, but it can be related with something formal, a mathematical expression. This is how I can represent the way I can solve this problem. Also, we can explore a big diversity of strategies and also capacity to be critical. Another thing is sometimes at school we learn operation properties and we don't know why they are useful, but when we compute mentally, they become very useful. So this is a way to say we learn this property, but this is very important to think fast about numbers. Also, it develops the sense of order, of logic, concentration, and so on. And most of all, prepare for daily life. In Portuguese contexts, we have percentage and decimal numbers. For example, when we work with money, we work with decimals, right? So it's very important to develop some skills to work with these numbers. We don't have many fractions in our daily life, but we have a lot of decimals and we have a lot of percentage also. And we also develop the capacity to communicate, to solve problems, to reasoning about, to make connections. And this is also the opportunity to consolidate some learning because things go so fast, and when we have some moments where we can discuss students' ideas, we can understand, as a teacher, we can understand if they really learn something or not. So it supports mental computation, it supports the development of numerical relationships, also the memorization of some facts and rules that in working with rational numbers, it's very important to make some more complicated numerical relationships and also to consolidate knowledge. And all this is what am I talking about, is to developing relational thinking. We need to think how to relate things, how to relate the knowledge that I have. So how can I do this? There's two fundamental elements. One of them is using mental computation tasks made with the purpose to develop a net of relationships. I need to put the emphasis on developing relationships between numbers and operations. And also, a big emphasis on promoting mathematical discussions. If we don't discuss, mental computation is not useful. So we need to discuss and to understand how students think, to understand what kind of knowledge am I as a teacher promoting in my students. Concerning the mathematical tasks, we need to offer some diversity of contexts and numbers, especially mathematical contexts, because when they go further in the school, they go even more formal. So we need to use the two contexts, also word problems and benchmarks. In mental computation, benchmark is very important because the human being cannot compute with all the numbers that we know. They need to compute very well with few of them and then to extend their knowledge to the more complicated one. And also have different cognitive demands on the tasks. If I ask you to compute a half plus a half, most of the students say, oh, this is the unit. 2 halves makes the unit, okay. But if I ask them to compute the second one with a high level of cognitive demand, it's more complicated, and they have to relate numbers necessary to solve this. So, and this can be and must be integrated in the teacher plan. And so, we have the opportunity to work with rational numbers all over the year, and not only when in the textbooks we have rational numbers. Rational numbers have we start teaching rational numbers since the grade 2. So we need to be aware that this is a very important issue in Portuguese curriculum. In implementing, how? I don't need to use the whole lesson, the whole day. I only need 50, 20 or less than this to challenge the children, as I challenge you here, to create some routines. And in these routines, we start to remembering strategies, how they had compute in the last tasks. Then I used in my research, I used the time PowerPoint. It was very challenging for the students. You can use other things, but the time PowerPoint works very well. And during this time PowerPoint, students have an individual work, and then we promote all class discussion. And here is the focus. Whole class discussion is the more important part of all this process, because we have the opportunity to share strategies, share ideas, and understand how they think to compute with rational numbers. In promoting mathematical discussions, teachers and students have important rules. Concerning the teachers, we need to listen to students, because sometimes they are really saying very important things, and we need to understand that. Also, to understand their errors and difficulties. For many years, errors was something bad, but error can be a good way of learning, a good opportunity to learn. And this, of course, also in science, sometimes an error can originate a big discovery. So, and also questioning, inquiry questions that we have already heard here today. We need to questions to challenge to every time. Concerning the students, they need to be comfortable to share how they reason, and also to face the error as a good opportunity to learn. They need to be critical, and this is something that we construct during the discussion. They need to be critical between her strategies and the strategies of their colleagues, and they need to interact with the teachers, but also with each other. And these moments, these mathematical moments, discussion moments, was a way to develop student strategies. It reveals that it's a good support to the students' construction of a mental computation strategies repertoire, and also provides good information to teachers about what kind of knowledge their students have about these issues. So, I think that mental computation is important, but without discussion is unuseful. So we need to talk about, we need to discuss, we need to share, we need to confront some ideas to learn more about how the numbers relates and how their operation is related. So, thank you.